Here's the history. No blue or black on that one. Here's the top, 20 some odd scores. All right, so this one's blue, not because it was too hard or because, something's wrong with it. It's just that it's such an important problem. And there'll be one similar to it on the final. So anyway, good one to practice on. Check those equations. I was very happy, though, overall, with how you guys did on this one. This one is not, we went over this in class. The only controversial part was 2B, where it's supposed to, I was thinking non-impulsive because it's a trapezoid. And I said trapezoids are non-impulsive, triangles are impulsive, but people pointed out, well, it's such a short time period, even though it's only 20 newtons. So I took either one, but I gave you a bonus if you said non-impulsive. Number 3, A and B are blue. Remember, if it's a basic impulse problem, but probably the most missed part of it was people got their wrist slapped for not including the I roof in the answer. If there's an I roof in the problem, there's an I roof in the answer, if it's a vector you're looking for. And both impulse and average force are vectors. This is a no, but if you're, in other words, this isn't on the black and blue, but main mistake was people didn't put enough words. They label things, or they got it backwards. Like they got the wake zone where in front of the object instead of behind the object. But the idea is you had to have your airflow lines. I mean, it's basically look back at what Owen did on the take-home test. We have that key posted. And that's basically what I was looking for here with some extra words. But wake zone's low pressure, laminar flow hitting the front of it is high pressure. The smaller the wake zone, the less the difference in low and high pressure, therefore the less drag. So if you can move that separation point back. Now, wake zones where all the turbulence occurs. Some of you thought the turbulence was in this laminar flow, but laminar is the opposite of turbulence. Okay, so turbulence is in the wake zone. Now, I made this one black because these are the kind of problems we're doing now, and this test was 2 weeks ago. So I pushed you a little bit. Remember, I can hold back 10% or 30 points, and as a surprise, and this was your surprise. Had about 10 people out of 55 or so get it right, totally right. Others got close, but it was missed by enough people. If I see Hall of Famers missing it, then I'm thinking, okay, this probably needs to be black if they're struggling. So anyway, make it black, no harm done, except the mental consternation. All right, I think we can, this problem on our test, and there will be problems like this, harder than this actually, on the final. You shouldn't have much problem with them, but this was new at the time. This one's blue. It was, I think you got, okay, so I got you on not putting a direction of motion. You might have got an illegal message if you tried to add drag. You can't, there's no such thing as adding drag. And normally you don't add friction either. There's a bizarro case you can put together where you would add static friction sometimes, but and you never add kinetic friction. But I cannot think of any case where you would ever add air drag because it always drains. Remember solo cup physics. It always drains energy out of your system. So if it's draining energy out, it's a minus. Okay, I'm going to take a look at it. First one's constant speed, so 0 acceleration. In the second situation, it seems like the arrows are wrong. Like the RW plus mg should be less than the buoyancy, but actually it's slowing down as it's rising. So it's already reached a certain speed, and now the speed's starting to drop. So you have negative acceleration, but it is still rising. It's just not rising as fast as it was in a deeper part of the water. Anyway. Okay, this one's blue. Let's blow up. So you need to put something in the drawing. I mean, I accept a lot there. Mine's not exactly fancy, but just that's where you write down your symbols and kind of try and piece them together. And then this in the symbol thoughts, now you're taking your equations and having to do manipulation, which we have to do here. So we manipulate it. Hey, by the way, sixth hour, I don't know if I gave you the homework. It's not due till Friday anyway, so I'll tell you tomorrow. But the homework is 3 and 4 on the unit analysis and the gold standard from 6.2. I told the other classes, but anyway. And then here, this one's critical, this box, because that's where you're actually isolating your variable. And then that gets extended down to the given section. And this is kind of the engine that runs the gold standard. Be very careful on this part. If you get this wrong, everything's wrong after that, and you'll cause yourself much headache. Okay, and also use the units that are given. Some of you were trying to, like instead of saying Mach 12, you were saying 12 times 331 and putting that number in there. You cannot do pre-work on these things. I've got to see the givens in that section as they are written up here in the problem. Okay, and then there's your conversions. I'll below that so you can see both at the same time. I save the miles, I save the hours. But notice the black part down the bottom, that's all the number crunching. That's only worth 5 out of 50 points. Only 10% of your points come from that. I would just blow it off and then, if I have time at the end, do it. All right, there it is. That's your black and blue for test 5B.